I'm streaming. Okay. All right, guys, come on. Come on. Come on. All right, come on. Come on.
The video's restricted.
Is it? That's so. I was about to look up YouTube on YouTube. Top 10 easiest gym leaders in Pokemon.
Can I watch that video?
Nah.
What about binging with Babish? You binging ice cream? That's a pretty good episode right there.
Top 10
What was that? Do you mean do I use chewing tobacco? I neither use chewing tobacco or own a firearm.
So there's a boomer rally. 2 hours of boomer music.
Wow.
Oh my god.
That's different. Oh, you saw this morning?
Wait.
Oh yeah.
It was just Pikachu dancing for an hour and 45 minutes. It's like a minute of introduction and then just wow, look at that. Top 10 creators.
All right, approved. You should be able to look at it now. All right, so as a review so guys, make sure that you have a piece of paper, a pencil, and you're getting your notes down.
Do we need a title to anything?
Yes, this is gonna be series. Yeah. Yeah. So, but a quick review for sequences. An arithmetic sequence. We add the same term D, which is the common difference. Difference. That says common difference. So add the same term D, the common difference each time. So their arithmetic sequence is you have AN is equal to A1, our first term, plus D, our common difference, times N minus 1. So each term, you are adding D, our common difference, to a previous term. So one way to express the recursive form is AN plus 1 is equal to AN plus D, which means the next term is equal to the current term plus our common difference. But another way to write the recursive sequence is that AN, our current term, is equal to AN minus 1, our previous term, plus the common difference. All right? And as a reminder, the common difference is equal to AN minus AN minus 1. Any term minus the term right before it. Now, geometric sequences, you're not adding a term, and you can add a negative number to subtract. You're not adding a term to find the next term. You are multiplying by a term R to find the next term. And remember, you can multiply by R, or you can divide by you can multiply, you can also divide by multiplying by a fraction. So essentially you're multiplying by the term R each time. So the explicit form is AN is equal to A1 times R to the N minus 1. So each term is equal to the first term times your common ratio to your term number minus 1 power. Recursively, AN plus 1 is equal to AN times R, which means the next term is equal to the current term times R, or the current term AN is equal to the previous term AN minus 1 times R. That's a quick review of sequences. Last thing is that R, our common ratio, is equal to AN, a current term, over AN minus 1, the previous term. So any term divided by the previous term, that's equal to R, our common ratio, which is what we multiply each time to get our sequence. All right. So make sure we are following along with our notes. What Are there any questions or people who are confused about what this terminology means? What A1 is, what AN means, what AN minus 1 means, what D means, what R means? Any? Are we sure?
Never mind.
Okay. These you're gonna have a term numbers in the sequence. So for example, an arithmetic sequence could be 1, 2, 3, 4, 5, where you're adding by 1 each time and starting at 1. And a geometric sequence could be 1, 2, 4, 8, 16, where you're starting at 1 and you multiply by 2 each time. A1 is 1 because 1's the first term. D is 1 because you add by 1 each time. So A1 is 1, A2 is 2, A3 is 3, A4 is 4, A5 is 5. Here, A1 is 1, A2 is 2, A3 is 4, A4 is 8, A5 is 16. Our R here, because this is geometric, is 2 because we multiply by 2 each time. 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. AN is equal to AN minus 1 times R, so a current term is equal to the previous term times R. So the current term 8 is equal to the previous term 4 times R, which is 2. So A is equal to 4 times 2. The current term, let's look at 3. The current term 3 is equal to the previous term 2 plus our common difference 1. So 3 is equal to 2 plus 1. Okay? Now, all right. Any objections if I move on? Are people still getting things down? Getting things down, or
You're
okay.
live streaming. Make me go back.
Okay, that's fair. Sorry, I'm clearing annotations. We're taking notes on this. I cleared the annotations from second block. All right. So using the formulas that we got from last slide, we can find the explicit and recursive formula for each. So first of all, is this arithmetic or geometric?
Arithmetic.
Arithmetic, because we are adding what each time?
7.
Add 7. 4 plus 7 is 11. 11 plus 7 is 18. So D is equal to 11 minus 4, or 18 minus 11 is equal to 7, because this is an arithmetic sequence. So this sequence is arithmetic. All right. What's our explicit formula? Look at your notes. What's the explicit formula? What's our explicit formula for arithmetic?
Oh my goodness.
AN is equal to A1 plus D times N minus 1. Let's look back at your notes for an explicit arithmetic sequence. This is our formula from our previous slide for an explicit arithmetic sequence. So AN is equal to what's A1?
4.
All right, plus what's D?
7.
All right, times N minus 1. All right, that's our explicit. That's our explicit formula. For our recursive formula, we'll have, first we have to indicate what A1 is. What's A1 here? And then recursively, AN is equal to, our current term is equal to the previous term. What do we do to the previous term to get to the current term?
Add 7.
Add 7. So AN is equal to AN minus 1 plus 7. All right, negative 2, 6, negative 18, 54. Are we adding by constant amount or multiplying by constant amount? Multiplying. So this is geometric. Hopefully we can sort of test out patterns to see that we're multiplying, not adding. All right, so how do we find R? Yeah. You sure? Okay. Alright. So, here we find r by doing a2 divided by a1. So r is equal to 6 over negative 2, or negative 18 over 6. This will simplify to negative 3. 6 divided by negative 2 is negative 3. Negative 18 divided by 6 is negative 3. Okay? So r is negative 3. Then, let's look at our explicit formula. It's an is equal to a1 times r to the n minus 1. So a1 is... What's a1 here? What's our first term? Negative 2. What's r?
Negative 3.
Raised to the n minus 1 power. Yes. Yes. Alright. Now recursively, we start out with a1, so this is explicit. The last one was recursive. So explicit means you can plug in n into your term number to the equation and get what the term is. Recursive means you write the term, you write a sequence in terms of a previous sequence number. So, an is equal to negative 2 times negative 3 to the n minus 1. For recursive, we have a1 is equal to negative 2, and an is equal to an minus 1 times negative 3. Each term is equal to the previous term times negative 3. Alright. Next problem. Geometric or arithmetic? Geometric. What's r equal to?
1/5.
R is equal to 100 over 500, or 20 over 100, or 4 over 20. That's going to be 1/5. All right, 1/5.
Yeah, you multiply by 1/5.
So, other representation of 1/5 is 0.2. Either one works. Now, our explicit form. This is geometric again. So, what do I write for my explicit form? What would I write? The full thing.
an
An.
equals 500
Good.
times 1/5
Good.
and the previous term.
All right. And then raised to what power?
N minus 1.
To the n minus 1 power. Then recursive.
It's an
Well, let's start with a1.
a1 500
a1 equals 500. And then an is equal to, each term is equal to the
previous term
previous term, an minus 1, times
1/5.
1/5. All right. That's 3 sequences in series that we've found an explicit equation for and a recursive equation for. What questions do we have? None? Some? Let's keep our heads up. Come on, Ty. Clear annotations. All right. We have sequences and series. All right. Sequence, series. We've seen sequences before, but we haven't seen series before. All right. Well, all a series is it's you add, it's the same amount of numbers as a sequence. It's that instead of a sequence is a list of numbers, a series says you take those numbers and you add them. All right? Right? Come on, Ty, wake up.
Yo.
All right? So the series is you add your terms, okay? Your partial sum is you add a finite number of terms of series. So to find the fifth partial sum, that is S5, of a sequence, we add the first term, the second term, the third term, the fourth term, and the fifth term. So let's find S5. S5 is equal to A1 plus A2 plus A3 plus A4 plus A5, which means this is equal to A1 is when n is equal to 1, 3 minus 2 times 1 minus 1, plus 3 minus 2 times 2 minus 1, plus 3 minus 2 times 3 minus 1, plus 3 minus 2 times 4 minus 1, plus 3 minus 2 times 5 minus 1. All right. So 1 minus 1 is 0. 0 times 2 is 0. 3 minus 0 is 3. 2 minus 1 is 1. 2 times 1 is 2. 3 minus 2 is 1. 3 minus 1 is 2. 2 times 2 is 4. 3 minus 4 is negative 1. 4 minus 1 is 3. 3 times 2 is 6. 3 minus 6 is negative 3. 5 minus 1 is 4. 4 times 2 is 8. 3 minus 8 is negative 5. So now we have 3 plus 1 is 4. Minus 1 is 3. Minus 3 is 0. Minus 5 is negative 5. So S5 is equal to negative 5. We also, if you want a formula to find the partial sum of an arithmetic series, so partial sum. So for an arithmetic series, we have an arithmetic series and a geometric series. All right. Okay. So our arithmetic series is going to be n over 2. Yeah. Mm-hmm.
$25? Wendover.
I don't think he can scroll down. No.
I assumed it was supposed to be some joke because it's
Jeez, again. Yes, sir.
So then you also have to get right that comparison arithmetic sum method as gender equals.
Oh, actually, I wanted to before he cleared the annotations.
There we go, the best smoker right there.
All right.
Sorry.
So an arithmetic sequence. All right. So an arithmetic series or a partial sum. That's equal to n over 2 times a1 plus an. And for geometric, that's equal to a1 times 1 minus r to the n over 1 minus r. These are arithmetic partial sums and geometric partial sums. So Sn would equal that, and Sn would equal that. That's S. That's Sn and Sn. Sn. S subscript n. Where? N. That's n over 2. -5, yes.
Oh, you're talking about uranium. Uranium is something less calorie a gram.
All right. Next slide. Next slide. All right. So now we're going to look at sigma notation. Sigma notation requires an index of summation, a first value of n, a last value of n, and the formula, your explicit formula in terms of n. So let's look at what this exactly means. This means you start at term 1, you end at term 6, you're adding all your terms together, and your explicit formula is 4n. So it's essentially saying you're adding term 1, term 2, term 3, term 4, term 5, and term 6. If your explicit formula is 4 times n, this is when n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and n equals 6. Term number 1, 2, 3, 4, 5, and 6. So this would be 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5 plus 4 times 6. All right, 4 times 1 is 4, plus 4 times 2 is 8, plus 4 times 3 is 12, plus 4 times 4 is 16, plus 4 times 5 is 20, plus 4 times 6 is 24. So 4 plus 8 is 12, plus 12 is 24, plus 16 is 40, plus 20 is 60, plus 24 is 84. Yes. So I find the first, what this notation is telling me is I add the first term, the second term, the third term, the fourth term, the fifth term, and the sixth term, because there's a 6 at the top. I stop at the 6th term. Then this formula tells me for n what each term will be. 4 times the term number. 4 times 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5 plus 4 times 6. So this would be 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 20, 24. Then I add them up. 4 plus 8 is 12, plus 12 is 24, plus 16 is 40, plus 20 is 60, plus 24 is 84. There's a cool tool that you can use on Desmos. To find it, you open up your keypad, you go to functions and you go to miscellaneous, then you click the sigma notation button. If you want to have your starting number at 1, your stopping number at 6, and then your formula be 4n, you will see on Desmos that will equal 84. So this, if you know what you're doing with sigma notation, this can be a useful tool for some certain test questions. All right. Questions? Okay. So this is new notation. My hope is that you leave this course having a pretty good intuitive understanding of directly looking at this and understanding what it means, because you're going to use these a lot in college level classes. And so you'll see these all the time. You have to have them, and you'll mathematically manipulate different series. And so because of that, you will because you're mathematically manipulating different series, you're going to have to having an intuitive understanding of what a series means is quite important. All right, so let's go.
But it's extremely salt. It's good. It's gonna be like seasoned salt recipe.
All right, now, so series. This would be so. Let's practice conceptually what's going on here.
How are you gonna put that into the calculator? Just tell me the shortcut right now.
So this, the shortcut is if you want to put in you can do a series in Desmos.
Okay, alright.
Wait, can you not do it on the
But if
calculators?
On the TIs.
I believe there is, but
Is it complicated?
I think it's Desmos is faster.
Ah.
Now, you can do 4m squared plus 4, so this would be 4 times 1 squared plus 4 plus 4 times 2 squared plus 4 plus 4 times 3 squared plus 4 plus 4 times 4 squared plus 4 plus 4 times 5 squared plus 4. Alright? 1 squared is 1. 1 times 4 is 4. 4 plus 4 is 8. 8 plus 2 squared is 4. 4 times 4 is 16. 16 plus 4 is 20. 3 squared is 9. 9 times 4 is 36. 36 plus 4 is 40. 4 squared is 16. 16 times 4 is 64. 64 plus 4 is 68. 5 squared is 25. 25 times 4 is 100. 100 plus 4 is 104. 8 plus 20 is 28. 28 plus 40 is 68. 68 plus 68 is 136.
What is that number next to the 6?
An 8. 68. 136 plus 104 is 240. So this series equals 240. Yeah, that's 4 times 1 squared plus 4, plus 4 times 2 squared plus 4, plus 4 times 3 squared plus 4, plus 4 times 4 squared plus 4, plus 4 times 5 squared plus 4. Because our starting number is 1, our stopping number is 5. Yeah. Yeah. So I didn't put the parentheses around the variable, but that's still correct because order of operations uses exponents first. Yeah. 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 All right, come on. Let's take our seats. All right. Come on. So, that's 240. Verify this in Desmos. This is going to be, if you think about it, 7 terms. The first term, the second term, the third, fourth, fifth, sixth, and seventh term. Each term is 30 minus the term number. This is equal to 30 minus 1 plus 30 minus 2 plus 30 minus 3 plus 30 minus 4 plus 30 minus 5 plus 30 minus 6 plus 30 minus 7. This is the first term, the second term, the third term, the fourth term, the fifth term, the sixth term, and the seventh term. This is essentially 29 plus 28 plus 27 plus 26 plus 25 plus 24 plus 23. We can always add this up. 29 plus 28 plus 27 plus 26 plus 25 plus 24 plus 23 is 182. What's... Okay. Let's see. Alpha... I went to math summation. Let's do alpha... Or we can say x equals 1. The stopping number is 7. Our formula is 30 minus x. 182. So here's how we put in our calculator. We did math. We went down to, if you want to do it in your TI, you go to down to summation. So you go to math, 0, summation. Our variable number is x. I hit the x button. Our starting number is 1. So our variable is x. Our starting number is 1. Our stopping number is 7. Our formula is 30 minus the variable. In this case, it's 30 minus x. Then we evaluate. We hit enter. And the answer is 182.
Okay, you said math.
Yeah, math. Down, 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 down. Go to summation. And so here you do. And then you, in your calculator, you put in x equals 1 over 7 of 30 minus x. You hit enter. And after you hit enter, you would hit 182. All right, come on. If you're disengaged, re-engage. All right. Were you guys still getting stuff down from the previous page? Okay. All right. Infinite sum. All right. So once again, please make the choice to engage and pay attention. So an infinite sum is when now your starting number is 1, but our stopping number is infinity, which means you add an infinite amount of terms. Yes?
What's the practical use of this?
This is used in computer science all the time. Like if you want to create a rule where you add a whole bunch of terms that follow a pattern. Yeah. Now, for example, you're adding a bunch of terms where, for example, you start at 1, you add an infinite amount of terms, this is 1 over 2 to the n. Okay? Now, let's look at, do you remember my Zeno paradox story with Zeno the frog? Zeno the frog jumped half the way to his destination each jump.
Oh.
Yeah. Well, let's think about this. I'm Zeno again.
Oh god.
Ribbity robbity, hippity hoppity. Alright? The distance from me to the wall, we're going to call that 1 unit, right? This formula will indicate how much I approach the wall with each jump. 1 over 2 to the n. The first term is 1 over 2 to the 1. 2 to the 1 is 2. 1 divided by 2 is 1/2. I get halfway of 1 unit towards the wall, right? Then the next term is 1 over 2 to the 2. 2 squared is 4. Alright? What's 1/4? So I get an additional, I add 1/4. So I add a 1/4 of a way to the wall. Yes, Dylan?
So this is basically a super task.
Yeah.
Oh, what?
It's a computer science term.
What did you say?
He asked if this is a program command that you can
Yeah,
do with
what
computer
was
science.
the word?
Super task.
Oh.
Yeah. My bad. So 3. So n is 3. 1 over 2 to the third is 2 to the third is 8. 1/8. I get additional 1/8. 1/16. 1/32. 1/64. Right? And if I get infinitely close to the wall, my distance traveled becomes 1. Because 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64, I keep on adding smaller rectangles, but if I add an infinite amount of rectangles, right? If I add an infinite amount of rectangles, I get infinitely close to 1, which means I converge to 1. So what does it mean to converge? Converge means that you have an infinite series. So, an infinite series, sums to a finite number. Sums to a finite number.
So a real number.
Yeah.
It's the same.
So I add up my sequence an infinite amount of times, and I'm left. And after adding an infinite amount of numbers, it actually converges to an actual number that's not infinity. If it diverges, an infinite series, infinite,
I know you can see it.
just 1 second. Sums, come on, y'all.
I mean,
No, because it says
An infinite series sums to either infinity or negative infinity. So if a series converges, it converges to a specific number. If it diverges to infinity or negative infinity.
What is under sigma in the top left?
-1 or n equals 1.
Okay.
Yeah. So let me redraw this.
That'd be good.
N equals 1. Stopping number is infinity. 1 over 2 to the n.
so you know how you say,
Yeah.
but it's not just a long presentation without a typo.
Well, that's not a typo. That's just, it looks small.
no.
No, that's a typo. Yeah.
Is that so, Mr. Law?
Yeah. So I it's just easier if it starts at 1 instead of starts at 0. You could potentially see series that start at term 0 instead of term 1. So you gotta get
Infinite?
Yeah, I was gonna ask that.
infinite.
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 Infinite spelling.
What was the infinite spelling? You never stopped
Shut
saying
up,
it.
Joe.
You just keep never finished the first time.
You just stuck saying.
Wait, what? I'm trying to see what you got.
I think it's pretty much.
What I used to think when I was like, I never get vision. So I was imagining it was like a room.
Wait, do you guys have enough time? You guys have enough time to get it down? Alright, I'm gonna say, because you guys didn't say yes. You guys didn't say. Okay. So. Oh, not responding. Come on. Oh, here we go. An arithmetic series always diverges. You just have to think about it. If you're adding or subtracting, if your next term in the sequence is you find by adding or subtracting your common difference, each term is going to be larger or smaller in absolute terms than the previous term. Because each term is you're either adding a value or subtracting a value. So if you add all of those terms up infinitely, each next term of the sequence is going to get a little bit bigger or a little bit smaller. And if you add up an infinite amount of terms, eventually terms of the sequence will get infinitely large or infinitely small. So an arithmetic series is always going to diverge to negative infinity or positive infinity. And the geometric series only converges if the common ratio is absolute value of the common ratio is less than 1. Because if you multiply by a fraction less than 1, then each new term becomes smaller. And if each new term becomes smaller, you can add up an infinite amount of terms and not lose control and go to infinity or negative infinity. But if your R value is greater than 1, that means each new term has a larger absolute value than the previous term, because you're multiplying by a number greater than 1. And if you add up an infinite amount of terms where the absolute value of the terms increase, then the series is going to diverge. So let's see whether each term converges or diverges. And please just cell phones away, headphones out of the ears. It's pretty simple. 3 plus 5 plus 7 plus 9 plus 11. 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11. All right, so is this arithmetic or geometric? Arithmetic. Does this series converge or diverge? So all right, let's please stop playing that music. Jaja, can we turn off the music, please?
How do you know what diverge is?
What does an arithmetic series always do? All right. What about this? What about this series? Is it arithmetic or geometric? All right. What's our common ratio?
Some fraction.
Well, how do we find it? Our common ratio is 1/2. 4 divided by 8 is equal to 2 divided by 4 is equal to 1/2. So R is equal to 1/2. Is the absolute value of 1/2 less than 1? Yes. So do we converge or diverge? Converge. All right. Is this next problem geometric or arithmetic? Geometric. What's our common ratio? 3/2. Geometric. Let's see their common ratio is 3 over 2. All right. Defined R, that's going to be equal to 3 over 2 divided by 1. So 3 over 2 divided by 1 is 3 over 2. It should also, we can check by doing 9/4 divided by 3 over 2. 9/4 divided by 3 over 2 is 9/4 times 2/3. 4 times 2 is 6. 3 times 9 is 18. 12. This is going to become 3/2. So 18/12 divide each side by 6. That becomes 3/2. So R is equal to 3/2. Okay? Now, if R is equal to 3/2, is the absolute value of 3/2 less than 1? No. Does this converge or diverge? Diverge. All right. Now, for number 4, are we adding and subtracting or multiplying, dividing? Adding, because what do we add each time? 2/3. So this is arithmetic. D is equal to 2/3. All right, if this is an arithmetic series, does this converge or diverge? Diverge. All right. That is the lesson.